Now, typically speaking, when you're creating a function, right, a function takes some input and it does some sort of computation with it, traditionally. Because of this fact, you generally want to use set delayed, right? So let me explain why that is. Suppose in a traditional math setting, um, suppose you see this, right? F of x is equal to sine of x. You don't see this and think, when you see f of x is equal to sine of x, what that should kind of signal to you internally is, okay, in the context of, this part of the, problem or textbook or whatever it might be, if I see f of something, I'm going to take sine of that something. And, it doesn't really matter if it's f of x or f of z or f of hello or f of goodbye. It just matters that this variable is the same as this variable. You don't really care what this letter is, and you're not trying to evaluate it right away. You are delaying the evaluation of the right-hand side until you actually see f of x somewhere, and then the x is going to have some value like, pi halves or whatever. The same thing is true here, right? When I define this function, I'm not saying, oh, I need to compute x cubed plus 3 right now. Please evaluate immediately. I better use set. You want to use set delayed because the right-hand side evaluations should be, or the right-hand side's evaluation ought to be delayed. So what happens here is that anytime we see func of anything, whenever we see this in some sort of computation, it's going to be replaced by anything cubed plus 3. The fact that this is x, again, it doesn't matter. It could just as easily have been z or birthday. It's just something, and then for the purposes of referring to it on the right-hand side, we're going to call that something x. And indeed, in Wolfram language, if you've seen this before, where you have like a variable and then an underscore, that very literally means what I just said. The underscore just means something, any one expression. And we're going to call that any one expression x so that we can talk about it consistently on the right-hand side here. So if we were to give this function the input 2, right, it works just fine. 2 cubed plus 3 is 8, plus 3 is 11, and there we go. And it's worth noting, you may see me use shortcuts occasionally. When you're working with a function of one variable, or if you're composing a bunch of functions of one variable, there's a special form you can use called the prefix input form, or the prefix operator, in order to apply this. So we can say func at 2, and that's just the same. Now, this isn't as useful as it once was. So I wanted to do all these things. You could save yourself having to type all the brackets that go with, say, sine and cosine and tan and exp and func, right? This used to be really handy because it was very annoying to type all the brackets. But now we have autocomplete in brackets. So if I were to just type sine and then a bracket, I get my closing brackets and the highlight, cosine, tan, exp, func. And you can see wherever I click, it's going to indicate to me kind of where I am in the structure, show me which brackets are associated with the expression that my cursor is a part of. Sorry, this should be a 2. And I can run it, and I get the exact same thing here. And it's the same number of keystrokes as doing this, or really even less, because typically to type an @ sign, you need to do Shift 2, whereas for a bracket, you can just type it on your keyboard. So it's a shortcut, but probably only see it for single inputs here instead of the chains like you used to see. Okay, so just a note that functions can take any number of variables, hopefully unsurprisingly. All you have to do is separate them with a comma. And really what this is saying, just like the above is saying, when you see func of any one thing, call it x, and then replace it with x cubed plus 3. Here we've got func of a, b, and c. So func of any three things, call them a, b, and c respectively, and then transform them like the right-hand side shows here. So this is going to give us 1 cubed plus b squared minus c. Here's a different one where we're going to have a message, a color, and a font size. And we'll just show you how this looks in action. So we can shout, wake up in red at font size 14. And here, because we are shouting, the font size is simply too small. And if the font size is less than 48, we're going to set it to 48. So we have bumped the font size up to 48, and we're yelling, wake up, and we're putting a yellow background on it. And if we do this here and we shout wake up at size 64, we will keep our, we'll get a red background because we didn't use a red one. And we'll keep the increased size. And so here, this is just a point to show that, a function can take any sort of input, say a string, a color, and an integer. And that works just fine. There's nothing in here that's specifying that any of these inputs need to be restricted to a certain type. They can be anything. With that being said, it is a good idea, especially if your code is going to be used by others, to add some restrictions to what can be typed in. So the way you do that is, if you look at these underscores, again, the underscore means any one thing, and then the left-hand side is just a name for that one thing that's going to appear again on the right-hand side. So see here we have message or monosodium glutamate. And we see that if we kind of click on that, we'll highlight all instances of it in the expression, which is handy. If we click on font size here, we see that that's where this is specified. So any one thing, the name for any one thing, and then we're going to specify that the head of any one thing has to be, say, string, or it has to be RGB color, or it has to be integer. And here, remember that cat is this picture of Meech. And remember that shout with the right input requires the first input to be a string. So what happens if we provide it with something that is not a string? It just doesn't evaluate at all. It just says, well, I only know what to do if you give me a string here and a color here and an integer here. And we did get those right, but here we did not provide a string. And so it just doesn't evaluate at all. And again, this is good when you're sharing your code with others, but it can also be good when it's just you using your code. The reason for that is that in Wolfram Language, you can do some computations you really might not have expected. For example, to make it explicit here. Here, sine is taking the sine of all the brightness values of these pixels, basically. And you could do the same thing with tan, which, because if you look at the way tan looks, basically functions as like a contrast enhancer. So you can see it's made the whites more white, the blacks more black. Or I guess it maybe just makes the whites more white because the tangent here is only going to be seeing positive values. So it's really only this first part of the curve, or the second part of the curve, I should say. This is kind of a way to apply a histogram to an image, or use those kinds of sliders that you might see in an image editing program. But the point here really is just that you might not have expected to be able to do this. It would be very reasonable not to expect to be able to do this. So sometimes if you don't restrict the types of input that your function can take, you can get some unexpected results because, maybe your function is taking the sign of a cat, which you didn't expect it to do. And sometimes these unexpected results can be expensive to compute, and you can just sit there waiting for your function to evaluate because you fed it something that you figured would, work, and it's doing something weird in the background that you didn't expect. We have a question about Notebook Assistant from Andy Medina, or Andy Medina. Sorry if, I guess one of those is mispronounced. But getting an error message when trying to use Notebook Assistant, which I have not seen that one before. I think if you email support@wolfram.com, they can probably get you settled really quick. Our support team is very fast and helpful to respond in my experience. But I have not experienced that one, so I'm sorry, but I cannot help you on that. Okay, so back to functions here. Just a note again, functions can take any type of input in general. So sentence scrambler here, we're going to give it this string that says, hello, it's nice to be here today, teaching you a bit about syntax and functions so that we can learn tomorrow about, say, data and function visualization. And what this has done is we have split up the string based on its spaces. We have randomly sampled the sentence so that we've reordered it, and then we have put all the strings back together with spaces in between them. And so now the sentence reads, bit so about here, data learn, teaching to visualization. Hello. Can you functions? It's about nice that today, P syntax and. So you can you can scramble your sentences. You could shuffle up a picture of, an affogato. You can make a wiki word cloud where you feed it some topic, and then it's going to make a word cloud of the words in the Wikipedia article about that topic. So here's the word cloud for the wiki article for rattlesnake. So a little subtle here maybe, but this is not like cached or anything. We have gone to Wikipedia and actually grabbed the topic page for rattlesnake, similarly. I wonder here if I search for Champaign, Illinois, where Wolfram is headquartered. Here we go. Here's a weather plotter, which is going to do something somewhat related where we give it a city and a date, and it's going to make a plot of the temperature here. So let's say 2019-5. What is this? Okay, some weird error based on some extra package I have. But here is the weather for, say, May 2019 in Champaign, Illinois, with the temperature in degrees Celsius. And, let's do last month, maybe this month. And here we go. See, it's kind of all over the place. So functions, really the point is just that the functions that you write can really be rather general. They can be mathematical functions. They can be string operation functions. They could be image editing functions. They could be functions that talk to the web to grab data from Wikipedia or from our weather data function. We could do a few more. We could say, here's element mass, and it's going to take some element. And we could say, we're going to take the string and we're going to use one of our built-in interpreters to interpret it as an element. These are really useful for data analysis, by the way. I'll talk about that in just a second, even though it's not exactly related to the talk. So here's this element mass. Let's try gold. Okay, entity value, unknown property. That's weird. I knew it. I knew it. You saw me try and type atomic here. There we go. So there we go. We get the atomic mass of gold in atomic mass units, or maybe the atomic mass of molybdenum. There you go. So you can write functions that are very general that access all sorts of things. Like I said, I do want to talk about interpreter. Suppose you have like a CSV with a bunch of countries in it and stuff. And then don't mind me here. Let me use 2 lowercase. So suppose you have like a CSV where people have filled out some data in a form about where they live. Countries. Right, there you go. What you can then do is you can say, oh, okay, well, I've got this list of countries and I want to make a visualization, but how do I actually do anything useful with this? It's just a bunch of strings, right? What do I do? Well, the first step is to learn to type, unlike me. Use the country interpreter on the list of countries that you've imported. And there we have actual countries. This one has failed. I wonder which one that is. Antarctica. Okay, so that's not interpreted as a country. But let us go ahead and take, I wonder if I just run this again, I get rid of Antarctica. It's pretty easy to get rid of a failure like that, but I don't want to get too in the weeds. Oh, now we get more failures. Two there. Okay. Let me delete missing. Okay. There we go. Nice list of countries. So what we could then do is we could do something like, say, counts of country entities. See how many we have from each country. We should have about 1 person from each country, given that there's more than 100 countries. And I only asked for 100. And then we could do something like, okay, well, where do these countries exist in the world? Then you could see, okay, the people who have responded on my form where I'm importing the data, here they are. And, maybe let's do this a little bit longer. Let's say you have 500 responses. Okay, just going to do this a slightly different way, just for the sake of the example. And now we can see, say, how many respondents we got from each country here. So in your case, you probably would not have to deal with this, but because I'm making this artificial data just to show a point about interpreters, of course, I must deal with it. And there we can see how many people responded to our form, for example, from each country that we counted. And so this can be really useful. There are a lot of different interpreter types. I just kind of want to point that out. I mean, I was not kidding that there are a lot. Basically, any sort of thing that we can have information about, anything that you might see in Wolfram Alpha, it can be understood as an interpreter, What are the primary contracted muscles of downward facing dog? Here we go. My wonder. So aside from that one error here, apparently, well, that's a lot of dang muscles to be worked by one pose. The power of yoga, I suppose. With that little digression out of the way, just because I wanted to point out how useful interpreters can be for data analysis. Okay, pure functions. So it's often the case that when you're, doing some programming, especially if you're doing some like live programming that you're just kind of working through, thinking about, working on a problem, it's not always the case that a function that you want to use is something that you want to use more than once. And it's, if you're not going to use it more than once, oftentimes there's not really a lot of sense in giving it a name so that you can refer to it later. That's the primary reason you would give a function a name, is so that you can refer to it later. So for these sorts of cases, what we call pure functions are extremely useful. And if you want to write a function like this, all you got to do is you use this sign, which in Wolfram language we call slot. And then, as I often say, depending on your age, you might call this an octothorpe or a pound sign or a hashtag. You just use that to represent your input. And then when you're done writing, you close off the function with an ampersand. So for example, here's a function that takes an input, that's the slot, and multiplies it by 2 and adds 1. And then once we're done writing it, we put the ampersand. And now this works just like any function. 2 times the input plus 1, and we're going to act that on 2. And that gives us 5. So this is, do I mention this? Whoops, I got out of full screen. So here, this is the same as, say, doubler and adder input, or, call it whatever you like. Right? But maybe I just want to do something like this once, and I don't want to clog up my namespace, and I don't want to define an arbitrary dummy variable. Because remember, this could be X, it could be Y, it could be Z, it could be birthday, it could be cat, it could be dog. It doesn't matter what it is. It's just a name that I give the input to refer to it on the right-hand side. If I use a pure function, there no longer is a left-hand side or a right-hand side. It's just a thing. And so I can refer to this without having to give the variable a name. It can just be slot. And just like with named functions, pure functions can take any number of inputs, and the inputs can be of any type. If you want to use more than one input, just call them sequentially, number 1, number 2, and so on. And so here's a pure function that takes 2 inputs, 2 to the 3, for example. And this would be equivalent to right? It's the same thing. Here's one that takes 3 inputs. It works exactly the same way. And if you use pure functions with mapping, you can do a lot with very little code. Let me actually do one quick motivation for pure functions here. Suppose you wanted to check a list for numbers where numbers n, where let's say 2n plus 1 is prime. Could do prime q is a function that checks whether its input is prime, just for reference. So we could do something like this, and then we could say select these are the numbers where 2n plus 1 is prime. 1, 2, 3, 5, and so on. In all these cases, 2n plus 1 is prime. It's a pretty big list, really. But maybe I just want to do this once. Or maybe you can think of doing it live. We could do select range 100. And then in here, we could literally just say, well, I'd like to check whether 2 times my input plus 1 is prime, and call it a day. And it's the same exact thing here, except here I didn't have to define a function and give it a name and give the variable a name and all this stuff. I just did it right in place. So it's very nice to be able to do this. And so again, pure functions with mapping let you do a lot of things. Let's get a list of 20 words. Got some fun words in here. And let's just make a pure function. You know, a pure function can look like anything. It could itself be a list. So for example, consider the pure function That's perfectly valid. No reason why this couldn't be a pure function. Here, my pure function is going to be, give me the input, give me the first definition we have on file for the input, give me the synonyms of the input, and give me the string length of the input, and put all that stuff in a list. And I'm going to map this pure function across the random words. I don't know why I'm getting that weird little error thing. I think it's probably something else I have loaded. I should just restart my kernel and we'll be fine. Here it is. It's kind of a mess. Let's make it a nice grid. So we're going to sort the results alphabetically, and we're going to see what it looks like. So we've made kind of a basic little dictionary here just by writing this. This is the entire code for it. It's got a word. It's got a first definition. We don't have any synonyms on file for elusive, apparently. And we've got the length of the word. We could also do something like get its part of speech, you know. And here again, a pure function can be anything. So we're going to plot sine of the input times x. The input's going to vary the frequency. And there you go. Or here again is Meech, and we could binarize him to different levels. Binarize cat to a particular level given by the input, and we're going to binarize him over the range from 0 to 1 in steps of 1/9. And here we could colorize the connected components and then put them all together in a big, really bad example, a ripoff of an Andy Warhol picture or something like that.